So 2022 deferred paper 2 and working on question 9. A team of surveyors is mapping mountains. Their surveyors have a map showing the peak of the mountains D, E, F. On the map, the distance from D to E is 7.6, E to F is 8.2, and D to F is 3.8 as shown below. Using only the information above, work out the angle DEF. So that's this angle here. Give your answer in degrees, correct to 1 decimal place. Now, a good place to start here is check that your calculator is in degrees rather than radians, in case you were doing any other question in trig from before. So this is not a right angle triangle, so that is a choice between sine rule or cosine rule. You can try the sine rule initially if you want, but you're going to realize pretty quickly you're missing too much information, and therefore it has to be the cosine rule. So how do we use the cosine rule for a missing angle? Well, you always start with the side opposite the angle. So you should be writing down your cosine rule from your log tables. I'm just speeding it up a little bit, but please do always write the formula from your log tables. So 3.8 squared is equal to 7.6 squared plus 8.2 squared minus twice 7.6, 8.2, and then the cos of the angle opposite the side we started with, which is this missing angle. So maybe we'll just call that A for the moment. Actually, sorry, we'll call it E, sure, because it's at E. So I'm just going to keep that as E. Now, we want to do it in degrees to 1 decimal place. So I'm going to start by doing 3.8 squared minus 7.6 squared minus 8.2 squared. So all I'm doing initially is moving all the ones from plus to minus over the other side. Just be careful here, always with the cosine rule. These guys are going to go underneath. Now you can work any of these out separately or put them into the calculator at the end, but just show where you're putting all your figures. And then the last step will be getting the cos inverse of this entire thing. So we're getting the cos inverse of this. And then our answer will be in degrees. And then we'll round it to 1 decimal place. Okay, so I'm going to enter that into my calculator. So inverse cos of, I'm hitting my fraction button, 3.8 squared minus 7.6 squared minus 8.2 squared all over -2 bracket 7.6 bracket 8.2. And then we close the bracket at the end. So that is 27.497, etc. Now to 1 decimal place, 27.5 degrees. Okay, so that's that one done. The surveyors measure the map and find that the angle FDE is 85. So FDE is 85. So we now know 2 of the angles. This is 27.5 degrees. So the question says, using this value or your answer from part A, part 1, find the area of the triangle DEF on the map. Give your answer correct to 1 decimal place. Now, if I'm looking for the area of a triangle, when it comes to trigonometry, I'm looking at my formula in my log tables. So my trigonometry formula, half AB sine C, is what I should be looking for in my tables. Remember, the important thing is the angle has to be between the sides. So when I go to do this calculation, it is a half AB sine C. So it's going to be a half of any 2 sides and the included angle. So I'm going to do 7.6 and 3.8. And then it's going to be the sine of the angle between, which is the one I just filled in, which is 85. So that is 85. And I put that into my calculator, and I'm going to correct again to 1 decimal place. So half times 7.6 times 3.8 times the sine of 85. And that gives us 14. So 14.385. Now we're doing one decimal place, so that's 14.4. Now, if it is area, we should be careful that we are using the unit squared. Now, is there, yeah, it is centimeters, so we can put centimeters squared.